Hi friends, happy late arrival. Hopefully you have already watched the first video of me from a couple years ago going over Intro to Energy notes. So if you haven't done that, go watch that. What this video is going to go through is energy analysis using pie charts. So we're on the second page. It says page 4 on the bottom. And we're going to go through a couple examples of how we can represent energy changes using pie charts. So just a visual representation of energy. So this first scenario, we're assuming there's no friction and there is a car that starts at the top of a ramp moving. So it's got some initial velocity. It goes down the ramp and then back up. So no friction. We're going to first talk about how do we define our system so that the system doesn't gain or lose any energy. Right now, that's an arbitrary choice. We're always going to be able to pick what's in our system unless a problem tells us. So the system are the objects that could have energy in that system. So in this system, I'm looking at, okay, there's some height change. So I'm going to think about there's going to have to be potential energy, UG, gravitational potential energy. There's motion, so there's going to be kinetic energy. And that's about it. So the objects I want to put in my system are the car, the moving thing, that's so it can have kinetic energy, and the earth so that it can have gravitational potential energy. Okay, so on page 4, underneath the diagram, I want you to write the system is car and earth. And then the second thing next to that is energy storage modes. What are the ways that energy is going to be stored? We kind of talked through this. There's going to be UG, gravitational potential energy, and K, kinetic energy. So both of those are the types of energy that I could see present in this problem in my pie charts. So let's go ahead and try out these pie charts for A, B, C, and D. Pie charts are just general ideas of how the energy is represented. They're not meant to be exact. So we're going to kind of talk through what they might look like. So here's the first 4, A, B, C, and D. So I said there's lots of UG, lots of gravitational potential energy because there's lots of height. So gravitational potential energy is related to height. So the highest point in the problem is A, so I'm going to give that the most UG. Then as I go to B, C, and D, B has less UG, C has no UG. So that's an important thing we're going to do in problems is we're always going to set the bottom of the problem to be where UG is equal to 0. That might not necessarily be a height of 0, right? There might be something below that. But if that's the lowest point the cart goes, let's call that 0 for problem solving purposes. And you also notice B and D have the same gravitational potential energy. That's because they're at the same height, right? So B and D should have the same. A, I gave it a little bit of kinetic energy because it was moving. Should get more kinetic energy. We know as things go down ramps, they're going to go faster and faster. It lost potential energy gravitationally. So where did that go? It turned into kinetic energy. At C, it's all kinetic energy because, again, we're calling that 0 height there, so no potential. So the only place the energy could turn into would be kinetic. And then at D, we're back to 50-50. Conservation of energy. The pie chart didn't get bigger or smaller. We're not missing pieces of the pie. It's just transforming from one type to another. So if you need to pause the video at any time or rewind, feel free to do so, but I'm going to keep going. So let's look at scenario 1B. Same situation, but now there's friction on the track. So again, we need to define our system so that we don't gain or lose energy. So if there's friction, that's thermal energy, right? Friction is when you go like this, your hands get warm. As the cart goes down the ramp, what gets warm? Well, the cart gets warm and the surface gets warm. So let's add the surface into our system, the track. So under system for 1B, we're going to say it's the car, the track, and the earth, so that we cannot lose any energy, so that the energy is all staying within my system. So then what are the energy storage modes? How is energy stored? We're going to say UG, K, and E therm. I'm just noticing there's not a place to write system and energy storage modes for this one. You can write it under the diagram if you want. But now we have thermal energy, right? So let's go ahead and make those pie charts. How might they look now that we have thermal energy added? They would look like this. So the first one would look the same. Thermal energy, we always are going to start our first one saying there's none yet. No thermal energy in the first one. But as the cart goes from B to C to D, the friction, we're putting more and more energy to E therm. That track and the car wheels would be getting warmer and warmer and warmer. So E therm is an energy that only grows over time. It can never go backward. It's not a reusable form of energy. So where did that come from? Well, it was still the same height, so same UG for B and D. No UG at C. So where did that E therm come from? Well, it must mean we have less K. Less K, and at D only a quarter K. These are general ideas. They don't have to be exact, but they're showing us how energy is transformed throughout a problem. All right, we're going to do another scenario. Example number 2. So this is a person running. They're running at the bottom of a hill. They run up the top of a hill, and at the top of the hill they say, "Yay, I made it." On your diagram, there's 4 points, A, B, C, D. On mine, I've only got 3 little runners, but you can see where those are at. So again, defining our system. What objects need to be in my system so I don't gain or lose any energy? There's a height change, so we're going to put the earth in our system. We're going to put the guy in our system, the runner. And let's put the ground in the system. So there is friction, so let's put the ground in the system. So our system is runner, ground, and earth. How is the energy stored? Well, the energy is stored in a couple ways. UG, because there's a height change. Kinetically, because the person's moving. Thermal, because there's friction. And then this last one, E-chem. So since the person, what's giving them the energy to run up the hill is they're breaking molecular bonds in their own body, right? They're burning calories. That comes from E-chem. So why don't you pause the video here and try the 4 pie charts for A, B, C, D. So pause it and then I'll show you what I have. All right, here's what I've got for A, B, C, D. So A, there's lots of chemical energy. They've got they ate breakfast that morning, they're ready to go. And as they go up the hill, they're burning calories. So that chemical energy is decreasing. One thing I don't like about this answer key is it says at D there's no more chemical energy. That's only if they got up to the hill and died, right? Hopefully they've got their arms up, they made it, woohoo! So hopefully there's still some chemical energy stored at the top. Thermal energy would grow, like we talked about on the last example, because that friction, every time they touch the ground, there's going to be some energy turned into heat. Kinetic energy, I think it says in the problem, it says assume the person runs a constant speed. So kinetic energy is based on how fast you're going. So since it's the same speed, we're going to do the same kinetic energy over time. And then B, C, and D, we have UG getting bigger from B to C. And then since C and D are the same height, those are going to be the same UG. So make sure you've got something similar. Again, it does not have to be exactly this, but something like this. One more example, example number 3. So there's a block falling and then it comes to rest on a spring. So what are we going to put in our system this time? Well, the block, because it's moving. The earth, because there's a change in height, so we want to talk about gravitational potential energy. And the spring we should put in our system. So box, earth, spring. Again, if I'm going fast, feel free to pause. That's the best part about a video. And then how are we going to store that energy? UG, because that change in height. K, because the box is moving. And US, because we're eventually going to compress that spring and store energy in that spring. So pause the video now and go ahead and fill out A, B, C, D pie charts, and then we'll check them in. All right, here's what we got. At A, it's not moving, so it's all UG. At B, it said it was 3/4 of the height, so we're going to say 3/4 of the UG. At C, it said 1/4 of the height, 1/4 of UG, and we said the lowest point in your problem should be 0 UG, so there's no UG at the end. Kinetic energy is where that energy turns into. Until we get stopped by the spring, then all the energy gets stored in that spring potential energy, so we call that US. All right. What I want you to do now is work on worksheet 1. It is due tomorrow. So that is the next page, 4 pie chart scenarios. Have a great day.